Hello, everyone. I'm Stephen Hardy, Editorial Director of Broadband Technology Report, and welcome to this second session of the second day of the 2023 BTR Summit. This 30-minute session will cover how you can enable a safe network for generations. We at BTR, of course, thank all of our summit sponsors, but in particular, we thank AFL for making this session possible. While network security is, of course, always an important consideration, in this case, S.A.F.E stands for Sustainable, Accessible, Flexible, and Expandable. Building or upgrading an outside plant network is expensive and time-consuming, so the network needs to last for a long time, ideally generations, as the title of this session implies. Another consideration for network initiatives these days is the fact that both governments and increasingly major customers are beginning to demand improvements in sustainability in the networks they use. So to help walk us through some of these requirements, as well as how the S.A.F.E principle can help you meet them, it's my pleasure to be joined for a conversation by Josh Seimer, Market Manager for Service Providers and Multiple System Operators at AFL. Josh has worked in the optical fiber and ICT industries for 15 years, prior to which he was a U.S. Army infantry officer. He has and continues to serve in a variety of roles, including product, solution, and program management, and has worked with a range of customers, including large to small service providers, MSOs, utilities, co-ops, enterprises, and data center operators. Welcome, Josh.
Thanks, Stephen. Great to be here.
So let's get started. In the title of this session, we mentioned a network for generations. What do we mean by that?
Sure, we mean several things by generations. To do that, let's look at different aspects of the network and how it's used. There's generations of networking technology that the basic physical infrastructure needs to support. So for example, the same physical infrastructure that some of the early fiber to the home providers built to support BPON was the same infrastructure they used when they switched to GPON, and now as they're switching to NG-PON2 or XGS-PON. And ideally, it'll be the same infrastructure they use when they go to 25G-PON, 50G-PON, and so on and so forth. There's another series of generations of network technology in the wireless area, 1G, 2G, 3G, 4G, 5G, and before we know it, 6G, each of which have different implications for what they mean for the physical network, all of which required physical network connections in order to operate. And again, you want a physical network to last through those generations. And then there's generations of application technology. So microprocessor speeds, the software applications, all of those, the things that people are actually using to do things, which then drive traffic over the network. And those have impacts like changing people's usage patterns, changing the total amount of bandwidth, changing where and how they consume that bandwidth, changing the number and types of connections into that physical network. So that's an important series of generations that, again, you want a physical network to last through. And finally, human generations. In two senses, really, as human generations come by and they have different approaches, they have different biases in terms of the way things have always been done. A new generation comes through and doesn't have those biases, so they have a tendency to use the network differently, be more open to new uses of it. And secondly, because due to the expense and the amount of effort put in building a physical access network, we've seen in the past that those networks tend to last for human generations. In fact, as fiber was being built out, starting in the 80s and 90s, a lot of the times the telephone cables that were being pulled up to be replaced by fiber had been there for as much as a century. And they had served well for all that time. So ideally, that's what you want your network to last, is through multiple human generations, as well as many technology generations, before going to the expense and time of completely rebuilding a physical access network.
Now, I've already defined S.A.F.E as sustainable, accessible, flexible, and expandable. Could you provide more detail on each of these parameters?
Sure. Let's start in order. So sustainability. A converged access network needs to be designed so that its installation and operation minimize adverse environmental impacts, first of all. So the impact that the network installer and the network operator have, but also with the capability to support its users' sustainability goals. And that goes back to understanding future technology generations and having it last through those, because a lot of how we will improve sustainability broadly in society will be through new ways of working, new ways of living and operating, and the new applications which will enable that, all of which then will have implications for the network. Then the A is accessible, because as we adapt to these new technologies, make new connections, change existing connections to adapt through these generations of humans and generations of technologies, at the end of the day, someone has to go out there and physically make that change to the network. So the network needs to be accessible, both in terms of physically accessible to go out and make a physical change, as well as have accessibility of information about the network so that you know how, where, and where you can make those kinds of changes. Then the F is flexibility. So as we talk through these, especially the technology generations, we talk about changes in bandwidth consumption, patterns of bandwidth consumption, where and how it's consumed, what types of connections are needed. And so a network needs to have the ability to be reconfigured to accommodate new technologies, new business cases, and with all of which, for the network operator, are new revenue opportunities. But if your network is too inflexible to adapt to a new set of connections, a new set of technologies, you won't realize those business opportunities without substantial reinvestment in new construction. And so flexibility is critical. And finally, the E is expandability, because we know the pattern has always been, and there's no reason to expect this is going to change, continued rapid growth in bandwidth demand in aggregate. So you need to be able to expand the aggregate bandwidth you can provide, but also increasingly a growth in the number of individual connection points into the network. So you need to be able to expand the number of total connection points, and that accounts for the E in S.A.F.E. So sustainability, accessibility, flexibility, and expandability.
So one important concept within S.A.F.E. is the accessibility of information. What do you mean by that?
Sure. So as you go and you construct a network, you generate quite a bit of information about where things are, how they're connected. You go and you do testing. When you do splicing, you gather information about this is the quality of the splice. I tested it and got the loss specs. I did an OTR trace of this part of the network. I understand the loss from this point to that point. So all kinds of information about the configuration of your network. Now, the challenge is recording all that information in a useful format, so then when you have a question at some point in the future saying, okay, something has changed here, I have an opportunity. Let's say, for example, you're at the edge of the suburbs, and now a farm is sold to a developer and subdivided into 400 individual housing lots. You want to know, do I have the fibers available? Do I have the power available at this point that I can connect so many of those fibers to 1x32 or 1x16 splitters or whatever the ratio is, and be able to deliver service at this point, or do I need to do something different? That's just one example. If you have the information about how that network was originally constructed, you may be able to answer those questions better without having to send someone out to the field to do extensive retesting before you can even make a decision about where and how you can make new connection points into that network and accommodate that business opportunity that just showed up in your area. So vendors who make this type of equipment have worked on and provide things like Bluetooth connection technology, cloud-based apps that allow you to record that information in an accessible manner so you can retrieve it when you need it, as well as providing additional ways to gather network information along the way and record that, and then again, retrieve it when you need it. And we continue to work on additional ways to provide more and more useful information in an accessible format as you construct a network, so you don't have to go back out and regather that information when there's a change to be made.
So we've mentioned the growing importance of sustainability. What are some of the ways that fiber networks can be made more sustainable?
Sure. I mean, let's start with the simplest. We've demonstrated through various studies, through a number of organizations, that just the act of switching to an all fiber network from one that is completely or partially based on copper and electrical signals, that uses less energy and therefore is more sustainable. So that's pretty much a given, and I think that's fairly well understood across the industry. So then the question becomes, okay, given that you are deciding to build a fiber network to take advantage of that, as well as all the other benefits fiber provides, how do you do that in a more sustainable manner? And there's a couple of things. There's sort of the more obvious, but I would argue less significant aspect of it, which is you look at what the vendor is providing in terms of sustainability in their own business practices. Now, that's certainly important. And we, like all vendors, all manufacturers of fiber optics, are heavily committed to improving our own footprint. But that's only one part of the problem, because if you think about a cradle to grave scenario, okay, so thinking about the entire life cycle of a product and a set of solutions from cradle to grave, if you focus on what the vendor does with the manufacturer, with their internal operations, that's what we call cradle to gate. Well, there's a huge set of considerations gate to grave, and some examples of where vendors are looking at that are, for example, the process of getting items from our manufacturing facility and distribution center to the job site. So things like the foldable underground vaults that we've introduced. That's an example of where you take something and say, well, now instead of only being able to fit a handful of those on a truck, now you can fit many of them on a truck because they're collapsible, they're more compact. That's an example where then you save truck rolls, you save on the total number of trucks you need, and therefore that improves the sustainability in many ways. Many vendors are introducing more and more compact cabling solutions. But what does that mean? It means you can fit more fiber on a reel and use smaller reels, haul more fiber cable to the spot for the same number of trucks, the same amount of weight, and reduce energy usage and therefore environmental impact that way. So there's a wide variety of ways to do that, but the common theme is vendors considering all that happens from not just their own supply chain to when they produce something and ship it out of their distribution center, but also thinking about what happens after that point until that gets in the ground. And finally, the most important consideration, and again, going back to this theme of generations, is there's a big environmental impact from building an access network. Now, it's worth it because it enables the apps of the future, and it saves energy over legacy copper networks, but it's a significant impact. And so if you can make that network last for 30 years instead of 20, or 50 years instead of 30, and so on and so forth, make it last a much longer time, you have a lower net impact. And so being able to provide a network that has these characteristics of accessibility, flexibility, and expandability to adapt to future generations of technologies without requiring a major rebuild and another major construction project, that's probably the most significant impact to sustainability that manufacturers such as ourselves can have.
So certainly flexibility is important because it's hard to foresee what future challenges might be awaiting fiber networks. But what are some challenges that you think we're comfortable anticipating these days now?
Sure. We can already see ahead to some of the next couple of generations of optical networking technologies, for example. We're in the process, probably in the early stages, of moving from technologies like GPON to another generation, whether it's NG-PON2, XG-PON, XGS-PON. So we know that there's some challenges there. They use different wavelengths. You have the challenge of continuing to support GPON customers because you don't want to upgrade everybody's ONT at once. And you want to be able to ideally charge more for an upgraded service and keep your ARPU up to provide the return on investment for making that upgrade. So we know that things like upgrading to the next generation and then the generation after, we have some insight into the generation after that, 25 and 50 GPON, of what that's going to mean. So those are some things we can anticipate, and being able to deal with that challenge of providing that optical networking service and having the coexistence with the previous generation, so that, again, you don't have to upgrade all of your customers at once, and you can continue to gain incremental revenue from the innovators and early adopters of the next technology. So that's critical. We don't know much about 6G yet, but we do know that the trend has been to try to get more data through each individual node by having nodes cover a smaller area and using higher frequencies / shorter wavelengths in the electromagnetic spectrum to try to get that lower latency and higher aggregate bandwidth that applications demand. So it seems logical that this trend of having more wireless nodes covering smaller areas and therefore more connection points into the network, that we can be pretty confident will continue. And finally, the overall trend, of course, of ever increasing bandwidth demands from both individuals and businesses, and the trend towards more and more devices being connected to the network. And again, even if the final connection for most of these devices is wireless, whether it's Wi-Fi or 5G, 6G, et cetera, the fact that there are so many means you need more wireless connection points and therefore more physical network connection points to accommodate them all without swamping an individual node with too many connected devices. So those are some future challenges we can anticipate in terms of technologies. And then challenges we can anticipate also just in terms of normal human dynamics are things like, well, the suburbs will likely continue to grow. There will be subdivisions, especially if you're operating in those areas at the edges of the suburbs now. You may not know exactly when and where farms will be sold to developers and subdivided, but you know that's going to happen. So you can prepare for it. And you know that businesses are going to switch out. There will always be turnover, and a place that might be a small accounting firm office today might get changed to a business this next week or next year that has a much greater bandwidth demand. You might have a car repair shop that has one pattern of bandwidth demand move out and get replaced by a custom 3D printing shop that has a vastly different pattern of bandwidth demand and vastly different requirements for their connection. And so you can anticipate that changes like that will happen, even if you can't say that'll happen on September 26, 2024 at this specific address. So those are all examples of how we can anticipate a certain level of future challenges and scenarios that we need to prepare for, even without a crystal ball of being able to say exactly what's going to happen a year or 10 years from now.
So finally, Josh, it seems pretty clear how safe networking could be applied when rolling out new infrastructure, but can you apply safe principles to existing infrastructures as well?
Certainly. Let me talk about a few ways. So kind of in reverse order. So how can you add expandability to a network? How can you add flexibility and then accessibility to a network? And of course, as we talk about this, do this all in a sustainable manner. So let's talk about that first. So expandability, how do you add capacity? This is kind of related to, there's kind of a tie-in with this and the flexibility point. So might be easier to talk about a couple of them together. But first, talking about expandability and what are some vendors doing to enhance expandability of existing networks? Well, one of the things that we're doing is continuing to look at ways to put functionality in a more compact package. So whether it's cable with a smaller outer diameter for a given fiber count, or whether it's smaller splice closures that are able to handle a given number of splices, We're always looking at making things more compact. What that does is gives you a greater ability to add expandability, add capacity to existing networks with less investment in that infrastructure cost. For example, if you have an existing duct, whether it's one of these hybrid ducts with multiple microducts, or whether it's just a large duct with multiple cables blown through it, possibly in microduct separately, if you have a more compact cable, you're more likely to be able to get a given fiber count through whatever existing space might exist in that duct. So that's one way to address it. The smaller fiber closures, you're more likely to be able to get more capacity by adding a closure on an existing strand or in an existing handhole, potentially replacing a previous closure with that type of technology. We also think about ways you can add flexibility points to their network, whether it's hubs that are designed with modular components and with the ability to have both pass-through as well as split fibers. That then gives you options to add a flexibility point to your network where you can do multiple things and accommodate multiple types of services, whether it's, for example, a wireless backhaul that might need a point-to-point connection side by side with PON connections. For example, in the case of that farm being subdivided into 400 houses that I mentioned earlier, it's not just that now you have 400 houses that may want PON service, but you're likely to also be adding some kind of mobile wireless node, maybe 3 of them for the 3 major mobile operators, to cover that area now that there's more density. So you'll need that type of flexibility. And having products that can add those kinds of flexibility points into a network, those are critical. And of course, the accessibility comes with the design of those products, how easy they are to install and connect to the existing network. And the sustainability consideration, again, comes in when we think of not just the product itself, but the entire process of getting that product from our factory to the job site, in the air or under the ground, connected to everything, and then in operation for a long time. Again, as you have to make those modifications to existing networks, you can do that in a more sustainable manner, both in terms of how you do the construction and how long that construction lasts. So there are a number of ways that we do that we approach that problem of making the existing network more flexible, expandable, accessible, and finally doing all that in a sustainable manner.
Great. Thank you, Josh. That concludes this session on safe networks. Thanks go to AFL for making it possible, and of course, to you for watching. Next up on our program is another chat on networking technology that will start in just a few minutes. Hope you'll join me in switching over to that session. If not, have a great rest of your day.